Okay, so I decided to do a page-by-page talk through of, after seeing Stephen's thing, of my Neutron Decay Cosmology, especially considering the fact that I'm still at present unable to access it to do any adjustments to it, so it's sort of like a artifact of time at this time. So yeah, so the link to this Adobe product thing is available on a bunch of my videos, and I'll put it here, of course, and all the future episodes of this. We'll just do a page-by-page walkthrough, talk-through of Neutron Decay Cosmology notebook. So, yes, here we go. Frontispiece, cover. This is the concept of Neutron Decay Cosmology in sort of an artist rendition. Little dot at the top would be a neutron. Then we have a proton-electron combo. A piece of hydrogen is that big ball up there, and that's the decay of the neutron into hydrogen. And then it gathers, and that little funneling part is gravity and other binding forces gathering together those protons and electrons and condensing them until at the very end there's this tiny spigot where a neutron can fall out to fall back in, because the universe is a closed system. Even if it's infinite, which I'm not sure about anymore, but even if it is infinite, I still think that it works as a closed system. So this is the concept artist rendition of Neutron Decay Cosmology. Here we go. So in this cosmology, time is an infinitesimal. Time is represented by a Planck time, Planck second, which would be sort of like any of those balls would have a radius or a diameter of Planck second, or a Planck, and therefore it takes a Planck second to make a Planck rotation over the Planck thickness of time, is the way I'd put it. So as you see on the top, the first one that says flat, so that's because the rotation, we are the surface, the upper surface, let's say, of this. And that rotation is flat to us, and therefore we don't see it. There's nothing there. There's no evidence of anything happening. That's sort of not chargeless vacuum even. That is, but notice that there's spin. If you look down, that would be a, oh wait, this is getting all backwards for me. If you look downward, to me that looks like it's going counterclockwise. Okay, but if you looked from the other side and you were in the antimatter universe, it would be looking like it's going clockwise. Baryon asymmetry is because of this. And this is essentially the vacuum energy, is the rotation 90 degrees to us. That's the isospin. Is that rotation 90 degrees to us that constitutes the photon sphere sort of thing of the plane of the vacuum energy. That's the rotation. So when it's flat to us, we don't even notice it. A neutrino is sort of a wobbling one, so the various axes are showing at various times. There's the 3 AEM axes, and this might be a representation here. Boop. So this, let's say, is when it's stable and it's just doing nothing. But then it starts to spin. I can't really do this very well, but basically it starts its rotation and we start to see all these other aspects of it. Hence represented by a wobble. Okay, and then electrons and positrons, charge is inflows and outflows. Electrons are inflows, divergences, and positrons are outflows, convergences on our side. And notice that they are on the other side as well. Everything is balanced. Like when you have an electron inflow on this side, that's because there was an outflow to our side on the other side of the membrane of now. This is the membrane of now. There is only now. There is no, the past was destroyed to make the present. That's where we got our material from, to make the present from the past. And the future hasn't occurred yet, or hasn't. I love Lee's Smolins thing where it's just like, it's undetermined. We're not sure how it's going to work out. We'll find out, and then it will be the past, because we'll have known what it was. But we haven't found out yet. The mystery of the future. So this is a summation of the little membrane sort of in simple flows. And I think everything can be constructed from this. I think that all we need is neutrinos and charge elements, and you combine those to make a mass unit. But we're not there yet. And then this, page 3, is sort of like a general view of the topology, which seems donut shaped, but actually is not if you look carefully, because when you are on the upper side, when you go through the black hole, I do believe that sort of the truth is that you become antimatter, and then you go through a rotation of life as an antimatter. But because every piece of antimatter is constantly mimicked on the matter side, that as soon as you have matter, you have antimatter, and as soon as you have antimatter, you have matter. So it's sort of also is hard to notice that way. But I think that's an actually important aspect of the way the integration happens at the moment of inversion. So this is what I see as the topology, and sort of gravity and time are the yellow arrow. Okay, because over time, gravity gathers. Inflow, the condensation is on the top. That is where the event horizon would be. And on the bottom side, where we can't really see where those two green arrows are, that is the neutron decay side. From highest energy to lowest energy at the crux there, with the event horizon acting as a sort of like a one-way pressure valve release, where things are gathered over time until they're extreme, and then they are expelled. But notice how the membrane orientation works, so that you become antimatter. But gravity and energy density occurs on both sides, is symmetrical. That was 2. Neutron Decay Cosmology. Those were preface pages. Here. Why law of conservation? Because the universe is a single thing. While we see parts in it, its totality is a unity. It is a single piece. If you pinch here, then you've stretched there. There's reciprocity because there is a singularity to its totality. You can't do something somewhere without it being affected and distributed to compensate. It's a single thing. It's a really convoluted surface, but in some way it's a single thing. That's the premise of neutron decay cosmology. One neutron in, one neutron out. You cross the event horizon, you become vacuum energy, you get spit out at the lowest energy point where there's the biggest pull from the vacuum. You're filling a gap, you're chinking. Neutron by neutron, constantly. This is the flow. Okay, so what was that? That's page 5. Yes. What I propose, oh great. What I propose, I can't even read it back, this is too hard. I need to reset this. What I propose is simply that the interior of an event horizon is the energy surface of the universe. It is the event horizon is the vacuum energy. The reason the event horizon is black is because the vacuum energy is 90 degrees to us. The rotation, as I said in the picture, it's sort of like this. Seems there's nothing going on there. There's nothing there. But as soon as it starts to go like this, you notice it. Okay, what I propose is that the interior of an event horizon is the energy surface of the universe. We need to think of energy as being a dimension. The other side of any Einstein-Rosen bridge is this universe. And yeah, see inversion of the circle, which I'll get to over the course of this. I wish I had a really good diagram for that, but I really think that the inversion of the circle is the best representation of our manifold. Ooh. Yeah, it looks all childlike, whatever. Okay, so yes, fundamentals. This is page 7. Fundamentals. Gravity is, we use it for various meanings, you know, because it's a concept of a process sort of thing. But in that nature, gravity is the gathering of things. Okay, it's a curvature which brings things down. Okay, there's various ways of thinking about that curvature. I'm not sure that that is exactly the best way, and I might get into that. I really think that that's best represented by a gathering of the metric itself, that the graph lines should adjust. Don't leave it as a flat graph with this weird abstract curve. Gather those lines. Everything is going to be affected by that. That is the metric. The energy density of space is the metric. That determines gravity. When you have enough energy in a place, then you have matter. Okay, it's sort of like a phase change, and we'll get to that also. Yeah, gravity is a gathering of things. It isn't directed down, even though because of where we are it seems that way, but inward, compressing things. It's a measure of and when we use it as a measure, it's a measure of the density of empty space, the energy density of empty space, because it's how much energy is compressed in that space. When you're in the gravity field, there's an incredible amount of energy that is in that area. That there's energy flowing towards that place. That is gravity. And there's an energy in it. And it's also a curvature, and I like to think of it actually as the viscosity. And the thing is, it's less viscous. It gets more dense and less viscous, so that things want to fall into it because it's less viscous. It's an acceleration because it's less viscous. That's the way I like to think about it. But there's various ways to think about it. The important thing is that there's an innate gathering. The future is more dense. It's just the way things work. That's probably going to get mocked, but whatever. Like the nails and all that. There's only, and there's only actually the present. That time is an infinitesimal. Time is 1 Planck second long. Right now, it's happening. This is why there's no movement in time. We calculate time over the course of a number of events, and when you use calculus, you say, oh yeah, well, we know it time, we calculate infinitesimals, but it's like to accept the reality of there being no past. The past was destroyed to make the present, and that there is no future yet because it hasn't happened. There's the present as it's happening, and that is what there is. And it's kind of important about developing the topology, because if you think that there's time in a long dimension, I don't know, I'm showing you the text, really, you should be reading it if you're following along, which you should be doing, sort of thing. Yeah, by thinking about time as one-dimensional, essentially, or as a membrane, that changes the way you can look at topologies. You don't have a bulk, but it's a bulk. There's past. There's no past. That's a joke. That's our remembering, and each of us remembers it differently. So how true is that? Okay, how real is that? None of us can move in time. You can stand. You were always. Can we say, oh, we're moving toward the future? And it's like no, we're stuck in the present, where we are. But that's okay, because the present's always changing. Because we have a plank. We got a plank. Just enough to turn this direction or that direction in the direction of the turn determines the future. What else? Oh yes, and then in the larger scope of not just the topology of the grand thing, but just how photons function and stuff like that, I think of space as a continuous fluid of variable density. We're on page 8. Yes. Space is a continuous fluid of variable density. The density goes from 1 atom per cubic meter, and you can turn that into energy density if you want, to, what is it, like 10 to the 64? Or something in that ballpark. It no doubt works out with Dirac numbers, actually, the big numbers hypothesis, but I haven't worked out all those details. But probably that's the whole thing. It's like the difference of energy between the moment of the neutron becoming the vacuum energy and how low the energy density is after that neutron decays into a hydrogen atom, which is even if it happened here on Earth, it would be an expansion of 10 to the 15th times or something like that. So that means if you were doing it out in the voidiest void of space, where there's the very lowest energy density, where there's essentially, it's aching, literally it's being sucked. There's like a negative pressure pulling that neutron to that place. It's coming up into the lowest, energy. Where are we? Yeah. So energy density. Yeah. So that's the thing. It's the gap between those two. There's probably the large numbers, but I don't crunch numbers very well. It's like I'm looking at the big topology. But this is clearly the workings of it. Okay? Density, this is the range of energy density. It's insane, of course. Okay? But the density is its energy density. That's how we should measure space, is by its energy density, because that is a real density. When it's matter, it's excessively dense. We've got c-squaredness of energy already, just to have made any matter to begin with. So that's the kind of range we're talking about, just to begin with. This energy is the energy density, locally measured as gravity. That's how you can measure the energy density of free space here, is by measuring gravity. That's the energy density of free space. That energy density curves space because of its density. Not only a fluid, but a thixotropic one, or a shear thinning one. And I say that because it's also like, because there's energy, it's more dense. And when it's more dense, things move faster through it, or appear to move faster through it. So everything falls into it. Most viscous at low density in space, in very large, voids, clouds, nebula, things move very slowly there. And then as you get smaller and smaller, things get faster and faster. Most viscous at low density, less viscous at high density. And sort of like that quality creates gravity. This weird tendency for, gravity itself can be seen as it's a gathering of energy, as much as it's a gathering of mass. Mass is energy, it's all the same. Why? Why is it gathering? Because it's thixotropic, where it gets more dense and less viscous, so that it wants to fall into the dense places. We think diffusion is a natural thing, but diffusion applies to material objects. Diffusion of gases, they've got fields, and there's a complex nature of the singularities of those things. But energy is a thing into itself. It's a flow in the fluid space. Okay, if gravity rules, we're on page 9. If gravity rules, I think we'll stop soon because we're like 20 minutes already. Let's do these sensible chunks. If gravity rules, then there is a black hole in everything's future. this star, this planet, maybe it'll get blown apart, but eventually it'll gather into something. Gravity gets larger and larger, like that funnel. Eventually, the future of everybody, eventually, in theory, except for maybe one or two things, if you do the math, where it's like the same way that, you know, the wind on Earth has 2 points that are still points at any given moment or something like this. Like, I mean, let's not get too nitpicky and stuff. Gravity rules in the black hole in everybody's future, pretty much, eventually. You know, the curve of space is towards the more dense. Gravity says the next moment is more dense. That's pretty much the essence of gravity's actions. So the universe was created. Oh, no, this lambda was created, the cosmological constant originally, to compensate for this fact that it's like, well, if everything's getting more dense, then why like the whole universe should fall into like one or two black holes, but even those black holes should eventually find each other, and then the whole universe would just be one big flat black hole. That doesn't make sense. So we have to invent some compensation for that. And now we're thinking of dark energy and all of this, and I say that if we apply neutron decay cosmology, it's very simple. Neutron in, neutron out. Neutron in, neutron out. Neutron crosses event horizon. As soon as it touches that event horizon, it becomes locked in with all the other neutrons. It becomes actually touching the other neutrons. It's the vacuum energy. Oh, well, that falling through created enough pull in the total fabric of space-time to create the gap that's necessary for that neutron to appear in deepest, darkest space. Okay, that neutron appears traveling near the speed of light because it just fell through a black, it just fell through this event horizon where the gravity was insane. Gets shot out. Ding! Neutrons going through space, got 14 minutes of relativistic flight. Then it decays into primordial amorphous hydrogen, where, I mean, that thing's moving at still like good speed. So the proton and the electron get disentangled. Uh-oh. We'll get to that. But, yeah, so what if dark energy and cosmological constant are unnecessary because a black hole was in our past? It's a constant loop. You fall through, you expand. It probably takes about, who knows? I mean, just a guess for fun, 14 billion years on average for a neutron to decay and then re-enter an event horizon someplace in the universe. Who knows? Here we go. Neutron Star. Okay, each neutron has its characteristic relative place, but each neutron will then get separated and emerge at the lowest energy points as they appear, because energy is a dimension, essentially. The degrees of freedom go from all right? Like when you're a loose thing, you've got all kinds of degrees of freedom, but as you get compressed, you get constrained, your spatial, ability reduces. All of a sudden, point of inversion, those neutrons all spread out through the universe. This is happening so continuously. I mean, there's so many black holes. It all averages out to just this even flow. And, oh damn, I shouldn't have gone this far. Okay, so this is what happens. Each neutron, this is the water table. Basically, like the minimum energy level is the water table. These fall through and fill up the water table, and then they leak through. So we're at this surface of ball of neutrons, page 11, with gravity getting towards C. Maybe it's less than C. I'm not a numbers cruncher. It's really not that important. Limits are limits. They exist. They are what they are. The big scheme is the shapes of those flows. And then one more neutron and flip, right? All of a sudden, you have a catastrophic phase change that happens where the neutrons touch each other. There's no gap at all. The neutrons touch each other. A black hole forms, as we call it, black hole. I would just say event horizon. I don't think there's anything behind it. It's just the event horizon. The event horizon forms because it becomes the vacuum energy. Okay, but what we're left with is at the very surface of that, those neutrons that were near the black hole but not so quite, or like on the neutron star but close to the neutron star. I think that actually what happens is that when a black hole forms, there is nothing inside there. That's the, the event horizon is the vacuum energy 90 degrees to us. What we think of as the surface part is one layer of photons, a sphere of photons. Yeah, this one's worth a picture, I think. So what you're left with is like a sphere of photons at Planck, or 2 pi Planck frequency, forming this perfect shell, trapped over their own gravity. As a neutron falls in, a neutron is added to the surface. That can't be possible. Does it just add to the surface? Well, I guess it kicked off one. I don't know. Okay. Is there a flaw in my math there? Damn. No. Okay. It's the way it will all work out, I'm sure. Okay, it's just too perfect. So yeah, so there. Okay, and in the, let's say we're doing the inversion eversion of the circuit. Let's look at this for a second. So yeah. The frequency of is Planck because the gravity was so crazy. Each horizon is the standing wave, essentially, or like the photon wave that forms in the surface, because it is basically the vacuum energy, which is photons 90 degrees to us. And oh yeah, that's when I started to form this idea that mass is equal to E over c squared, because it's energy distributed over a Planck sphere going at the speed of light, which gives you 10 angular momentum, c squared, because usually it's a v2 squared, right? But you're going at c, so now it's c squared. So energy, mass, is a photon trapped over its own gravity. Is where I first got that idea, actually. But yeah, but I think that that's what we see. What we're seeing is this sphere of, it's the photons of that vacuum energy, and that's why it looks black to us, because they're all facing the wrong way. Yep, the event horizon is a membrane of photons in orbit around what was a neutron star. But now it's this weird hole in space that leads back to the antimatter universe, our universe, at the same time, because there's one membrane and it's just sides of a membrane. The neutrons are gone. They were each sent, and they were split up after the inversion and moved to all the lowest energy regions, pulled there by the pressure differential. And we'll get more to the pressure differential concept, the thermodynamics after this. Let's close off at, that was page 13 of 64. Yeah. So thank you if anybody paid any attention to any of that, because and I hope it made any kind of sense to anybody at all.